We will continue the presentation of CSEC Multiple Choice Practice Paper 6 with Part B, another 15 problems. This will take us from number 16 to number 31. A plot of land is valued at $18,000. Land tax is charged at the rate of 70 cents per $100. What is the total amount of tax to be paid for the land? In this particular case, the examiners did not make the choice difficult by causing the answers to look similar. Therefore, the challenge of arriving at the correct number of decimal places is eliminated. That we'll take a look at a little bit later. Multiplying or dividing by 100 changes the number of decimal places but not the value of the first digits in the answer. All we need to do is use the non-zero digits in 18,000 and 0.7. This turns out to be 126. Option B is therefore correct. So this 100 will not affect the value of the digits. It will just affect, if we are multiplying or dividing, it will just affect the number of decimal places, but will not affect the value of the digits or the sequence of digits that we have right here. As I said before, I would prefer to see in the options probably 1,260, 12.6, 12,600. In that particular case, we will have to be on top of our games and ensure that the calculation is done correctly. But by just having the 126 here being unique among the options, we are sure that option B is correct, and we do not even need to take a second look at what we are doing. It is 70 cents per $100. We may then consider that the rate is 0.7 per 100. This means that 0.7 will be divided by 100. That quotient is required to be multiplied by the value of the land. So we have the rate being multiplied by the value of the land. Dividing by 100 will eliminate 2 zeros in the numerator. So these two will eliminate these two. We have 180 there to be multiplied by 0.7. And it is equivalent to 7 multiplied by 18. The single decimal place has eliminated the trailing 0. So 0.7 will eliminate, as a matter of fact, the single decimal place here will eliminate the 0, and we'll have 7 multiplied by 18. 126, and that is option B. I think that the distractors would have been better if they demonstrated that the candidate should partially do the right thing. I am sure that the correct digits with varying number of decimal places would have ensured that each candidate had to be spot on in order to arrive at the correct answer. But because only one option contains the correct digits, then we just breeze through this problem as soon as we have discovered the right sequence of digits that must be in the answer. If we had a few different appearances, as I have discussed before, then it would have been more challenging, and the students would have had to ensure that all calculations are done correctly, especially manipulating the decimal places and the zeros. If x is an integer which satisfies the inequality 4 is less than 2x is less than or equal to 6, then which one of these may be considered to be true? Let us not make the problem more difficult than it really is. One may be tempted to dissect the inequality, then reassemble it again. That is not necessary. In order that 2 may be eliminated as the coefficient of x, we will divide by 2. For the inequality to remain the same, we need to divide each of the numbers by 2 also. So there we have the same inequality, and to get just x right here, we will divide by 2. We need to divide by 2 here and here also. So we have 2 is less than x is less than or equal to 3. The correct answer is option A. This problem involves a binary operation. This is just an instruction given algebraically. Pay special attention to the details and we will have no difficulty. First, write the left-hand side of the initial algebraic expression and the problem that we are required to solve. So we are going to put down both left-hand sides. The right-hand sides are written as templates. Let us put the 2 left-hand sides down, which is of course A asterisk B and 7 asterisk 28. The answer is given in a template. We have the fraction bar and we have the -1 that is a part of it right there. As the A is first and is placed in the denominator of the fraction, the 7 is first and is also placed in the denominator of the fraction. Notice that A is first, it is placed in the denominator. So we will have it. The 7 is first, we will place that in the denominator. As the B is second and is placed in the numerator of the fraction, the 28 is second and is also placed in the numerator of the fraction, like so. Whatever we have here, we do the same over here. 28 divided by 7 is equal to 4. We have 4 minus 1, and that is equal to 3. Option C is correct. Generally, the problem that candidates have in arriving at the correct answer in such a problem is that they always place the first letter first. In this particular case, they may place A in the numerator because it is first, neglecting the fact that the first one, which is A, belongs to the denominator. So if we pay special attention at where each one is placed, then we will have no difficulty in arriving at the correct answer. When 7 is added to 3 times a certain number n, the result is 22. The statement may be represented by the equation. Let us write that equation. 7 is added to. 7 is added to something. Let us leave a slot for whatever 7 is added to and demonstrate by using the addition sign that we are actually adding 7 there. So 7 is added to something. The slot remains. 3 times a certain number n. What is 7 added to? It is added to 3 times n. 3 times n is equal to 3 multiplied by n, which is 3n. Let us place 3n in the slot. The result is 22. The result is what the entire statement is equal to. It is equal to 22. The correct answer is option A. Applied problems, or what we call worded problems, most times drive the fear of hell into students. The problem may be attacked by separating it into sub-statements. Each statement may be converted to the form required. When the results are combined, the correct answer will be the result. This is making use of a problem-solving method that we call divide and conquer. So we have maybe not so much of a sophisticated statement of the problem, but just by taking a single glance, we might not be able to just write it down. Some candidates may be able to, some might not be able to do that. We divide the statement into sub-statements and write the appropriate expression for each part, combine them, and we will no doubt get the correct answer by divide and conquer. While reasoning out the problem, it is possible that some candidates may have 7 preceding 3n. The answer would still be the correct one because addition is commutative. The order in which we add numbers or expressions do not affect the result. So one might have, instead of 3n plus 7, they have 7 plus 3n. Does not matter. Addition is commutative. What we have there is just the square of a single term with its coefficient. So we have 8a all squared. We are squaring a term with its coefficient. In squaring a number, each letter or symbol involved must be squared. The coefficient must also be squared. So we have 8 squared, a squared. There we have it. In addition to that, squaring 8 is equal to multiplying 2 occurrences of 8. So we have 8 multiplied by 8 is equal to 64. That is what we mean when we square 8. (64a squared) is the answer. The correct answer is option D. The other answers are in line with the common mistakes that students make. They sometimes square one part and not the other. They also may multiply a number by 2 when intending to square it. However, the mistake that I see most often in my work is that the symbol or letter in this particular case is squared and the coefficient is not. I would have liked to see a distractor demonstrating this. The appropriate choice would have been 8a squared. So what I'm saying is that the most common mistake is that they square the symbol or the letter and do not square the number, and the result would have been that they would end up with an answer 8a squared, and I've not seen that distractor. But we do not have to include every single possible distractor. We will solve this linear equation. In the first step, we will flatten the equation. Flattening the equation means that we will eliminate the denominator. And in the case that we have quite a few denominators, then we will eliminate all of the denominators. And that will be what we call flattening the equation, getting rid of those denominators. Usually, we multiply by the lowest common multiple of the denominators. In this particular case, there is only one denominator, that is x. We will multiply the equation by x. By so doing, 3 will be multiplied by x, we will get 3x. And here, when we multiply by x, x will cancel with this x, we will have 2. And on the right hand side, we will have 1 multiplied by x, which is equal to x. So we have 3 times x, 3x. The x will cancel here when we multiply by x, and we have 1 multiplied by x on that side. The next step, we will transpose x to the left hand side. This x will be transposed here. Then we have this 2 will be transposed to the right hand side. So we have 3x minus x. This is a positive 2. Transposing this to the right hand side, we will have negative 2. We will have 2x is equal to negative 2. Then finally, we will divide both sides by 2. In dividing both sides by 2, the x will be eliminated on this side, and on the right hand side we have negative 2 divided by 2, and that is equal to negative 1. The correct answer is option A. We could have taken another approach in solving the problem. In this particular case, we could have taken another approach in which we first subtract 3 from both sides. This would have resulted in 3 being eliminated from the left hand side, and on the right hand side we have 1 minus 3 is equal to negative 2. So we have 2 over x is equal to negative 2. Then multiplying both sides by x will result in x being eliminated from the denominator of the left hand side, and on the right hand side we have negative 2x. Multiplying by x, x will be eliminated here. We multiply by x here. Negative 2 times x is equal to negative 2x. Divide both sides by 2 results in 2 being eliminated from the right hand side, and on the left hand side 2 divided by 2 is equal to 1. So 1 is equal to negative x. Then we reverse the equation, that is, we will have negative x on this side and 1 on the right hand side. Multiplying or dividing an entire equation through by negative 1 will result in a change of all of the signs. We need not specify multiplication nor division, just change each sign in the equation. So we need not say that we are multiplying by a negative 1, and we need not say that we are dividing by a negative 1 throughout, because any one that we use will result in the same thing. All we need to do is change each sign, and that will be equivalent to either multiplying or dividing by a negative 1. So by doing that, we have x is equal to negative 1, confirming that option A is correct. Think of a number, subtract 8 from it, multiply this difference by 3, the result is 21. What is the original number? Think of a number. Let us say that the number that we are thinking about, whose value we do not know, is x. So we do not know, we just say x. Subtract 8 from it. That's not difficult. Just subtract 8. Multiply this difference by 3. We need to multiply that by 3. The entire difference, all of x minus 8, must be multiplied by 3. That's it. The result is 21. The entire expression will finally be equated to 21. And that is what we have. We have a linear equation that may be solved by expanding the brackets as the initial step. So let us expand that bracket. We have 3 times x is 3x. Then we have 3 multiplied by negative 8 is negative 24. That is equal to 21. Then we have a negative 24 that we need to transpose. We do that by adding 24. That will cause the negative 24 to be eliminated from the left hand side, And on the right hand side we have 21 plus 24 is equal to 45. Dividing both sides by 3 will eliminate 3 from the left hand side. On the right hand side, 45 divided by 3 is equal to 15. So we are eliminating this 3 by dividing by 3. We divide by 3 on that side. 45 divided by 3 is equal to 15. X is equal to 15. The correct answer is option D. The greatest chance of an error in converting the statement of the problem into an algebraic expression is multiplying 8 by 3 instead of all of x minus 8. So instead of multiplying x minus 8 by 3, the biggest mistake that I see that we could have made here is just by multiplying only the 8 by 3. That would not have been too detrimental because no distractor catered for that. So if you did not see that you need to multiply the entire x minus 8 by 3 and you went on your merry way and just multiply just the negative 8 by 3, when you solve the problem or solve the equation, you would not have received any of the numbers that we have in the options here. Therefore, you would have realized that a mistake was made and you would have done the most sensible thing, which is, or the only sensible thing, which is to take a look at where you made the mistake. We could have taken another approach in solving the problem by considering that the 3 that precedes the bracket is actually in a multiplication relationship with the expression. So there we have it, same equation. So we could think that this 3 is in a multiplication relationship. Then we would need to eliminate it by dividing by 3. Divide both sides by 3 will eliminate 3 from the left hand side. On the right hand side, 21 divided by 3 is equal to 7. The brackets on the left hand side are no more necessary because they are only there to show that the entire thing is being multiplied by 3. Now that we have eliminated the 3, then the necessity ceases to exist. So 8 subtracted from x is equal to 7. That's what we have there. And we may finish up the solution of that problem by adding 8 to both sides. If we do that, 8 will be, this negative 8 will be eliminated from the left hand side, and on the right hand side we have 8 plus 7 is equal to 15. And that's all there is to it. We have arrived at our answer by using another method. We could have solved the problem mentally without going through the rigmarole. Make use of the simple principle that we apply when finding the inverse of a fraction. Namely, find the reverse of each task and perform them in the reverse order. That is what we do when we eliminate. That is what we do when we find the inverse of a function. And that principle will be used here also. Multiply this difference by 3. Multiply this difference by 3. What are we about to do? The last thing that we did was multiply by 3. What we are doing now, we are performing the reverse of each operation, and we are performing them in the reversed order. So the last thing that we did was multiply by 3. The reverse of that process will be first, because it was last. We need to reverse not only each arithmetic operation, but we need to perform them in the reverse order. So the last thing that we did was multiply by 3. The reverse of that process will be first. We will divide 21 by 3. So we divide 21 by 3 first. We get that is equal to 7. Subtract 8 from it. So we have that 7. The first move that we made was subtract 8. The reverse of this one will be last. So we are going to reverse that operation, which is we are going to reverse the subtraction of 8, which is the addition of 8. So we will add 8 to 7. The result will turn out to be 15. So 7 plus 8 is equal to 15, and we have arrived at our answer. So in arriving at our answer, we did the reverse of each operation, and we performed them in the reverse order. The principle is used in number trick games, as we will see on the next slide. So we have number trick games that students used to play on us from the time that we were in primary school. The same principle that we are discussing here are the principles that were used, and we thought that they were the greatest mathematicians on the face of the earth. From primary school, our classmates have used a trick on us in which we are required to think of a number between 1 and 10. Then what do? Add 2 to it. Then multiply the result by 5 and reveal the answer. So we will think of a number between 1 and 10. Add 2 to it. Then multiply the result by 5. After we have done that, we'll tell them the answer. And that individual who we have told the answer will tell us the number that we thought of. And that is magical. We thought that the classmate was of superior intellect, being able to read the mind or something. Let us say that an individual returned an answer of 40 after thinking about a number, adding 2 to it, then finally multiplying the result by 5. So let us say that an individual returned an answer of 40 after thinking about a number, adding 2 to it, then finally multiplying the result by 5. All we need to do is reverse the process by reversing each step and performing them in the reverse order. So first, divide by 5. The last thing we did was multiply by 5. The first thing we do is divide by 5. So we take the number 40, divide by 5, we get 8. Then we minus 2. 8 minus 2 is equal to 6. Because the first thing that we did was add 2. We added 2, then multiplied by 5. Now we need to divide by 5 and subtract 2. The answer is 6. The number that the person must have thought about is 6. We may check the accuracy of it by adding 2 to 6. When we add 2 to 6, we get 8. Then multiplying the result by 5, we get 40. So 8 multiplied by 5 is equal to 40. Now, you may go ahead and invent a few tricks of your own. And that you'll be able to do because you understand the principle by which we may arrive at the number that someone thought of by giving them a process. All we have to do is reverse each step of the process and perform them in the reverse order. The perimeter of a triangle is p centimeters. Which of the following formulae is correct? What do we mean by perimeter? The perimeter of a polygon is the measurement around it and is found by adding all of the sides. It's as simple as that. Perimeter, measurement around, found by adding all of the sides. So there we have the perimeter is equal to, let us proceed to add the sides. Let us add the sides. The first one is 6a, the second 3b, and finally we add 2c. That's all there is to it. The correct answer is option A, as we can see. Only a candidate who attempted area instead of perimeter could have been undone by the problem. The area of a triangle is given by a half base multiplied by height. In such a case, the height and the base must be perpendicular to each other. The two perpendicular sides are 6a and 2c, which would have made the area a half of 6a multiplied by 2a, which is equal to 3a multiplied by 2c. And that one is not in the options. Mary invests $200 for 3 years at 5% per annum. John invested $300 at the same rate. If they both receive the same amount of money in interest, for how many years did John invest his money? By using common sense, we may determine that John invested his money for 2 years. That's all there is to it. How would we know that? Consider the figures in Mary's investment. We see 2, 3, and 5. That's what we see. We see 2, 3, and 5. What about John's? Bear in mind that the investments had the same rate. The figures in John's investment were 3 and 5. That's what we have there. We have the 3 here, and the 5 is from the same percentage. These numbers are identical to those in Mary's investment, with the exception of the one that is missing. If the interests are the same, the missing number from John's investment has to be 2, since the end results have to be the same. So there we have John's investment with 3, and we know the 5 is from here. And we have Mary's investment 2, 3, 5. Therefore, if we have a 3 and a 5, the only one that is missing for it to be identical to Mary's investment is the 2. With x being the unknown time in John's investment, let us write an expression in which the interest on both investments are equated. Now, if it was not so clear-cut with the figures that we had here, then we could have used an equation. And it is the same type of equation that we are using, although we know that the answer is already 2 years. So there we have it. That is the equation for the interest on Mary's investment and the interest on John's investment. They are both equal. Multiplying the entire equation, we are attempting to solve the equation to show that the time is actually 2 years. Multiplying the entire equation by 100 will eliminate the denominators. The denominators are gone. Dividing an equation through by a particular common factor does not change the equation. Let us divide through by 100. This may be achieved in brief by striking off zeros from both sides. There we have that. Dividing both sides of the equation by a factor of 100. And first we eliminated the hundreds from the denominator by multiplying the entire equation by 100. 5 is also common on both sides. Let us divide through by 5 also. If we are not careful, the 3's on both sides will go by unnoticed. Let us divide through the equation by 3 also. The only remaining factors are the 2 on the left hand side and the x on the right hand side. So we have only the 2 and the x remains. Therefore, x is equal to 2. Although it may not be so important in determining the correctness of the answer, the numbers that cancel each other may be best crossed in the same way. This will help someone else to follow the steps that you use in solving the problem. It is not necessary because this is multiple choice. No one is too careful about the way that we solve the problem as long as we arrive at the correct answer. But if we need to do this on an essay type paper, then it would be a good thing to cross in the same manner the ones that cancel each other. So it is going to be plain to see which will cancel with which, in order that an understanding or just that someone may be able to follow the steps that we use in solving the problem better, then we may do that. A television set cost $350 cash. When bought on hire purchase, a deposit of $35 is required, followed by 12 monthly payments of $30. How much is saved by paying cash? To find how much is saved by paying cash, we first need to find the total hire purchase price. First, consider the down payment. How much is saved by paying cash? In order to do that, we need to find the total hire purchase price and compare that with the cash price. First, we consider the down payment. Next, add the 12 monthly payments of $30. We add plus 12 times 30, 12 monthly payments of $30. 12 multiplied by 30 is 360. So we have $35 plus $360, and that is equal to $395. We will finish up by subtracting the cash price from the hire purchase price. This is the hire purchase price. We will subtract the cost price from that, and we have $45. The correct answer is option D. The most blatant catch to the problem is the expectation that some candidates may not remember to include the down payment. By so doing, they would have found the answer to be $80. This would not have caused any harm because none of the distractors was $80. The wise one may revisit the problem and discover the error quite easily. So the most blatant catch would be that candidates made the calculation without considering the down payment, and of course we discovered that it would not be too detrimental, because if the down payment was not considered, the answer would have been 80. Students get 80, they would want to check to see where they made the mistake, and that would not turn out to be so harmful. The only cost will be the time that it takes to go back through the entire problem. In this circle with center O, the circumference is 20 centimeters. The length of the major arc AB in centimeters is, the length of an arc is a fraction of the circumference. The fraction involved will be determined by dividing the angle associated with the arc. In this particular case, it is 360 minus 60, and that is what the angle associated with the arc, that will be divided by the angle of one entire revolution, which is 360 degrees. So 360 minus 60 over 360, and that we multiplied. This fraction is multiplied by the circumference, that is given as 20 centimeters. The correct answer is option C. Because the circumference is already given, some candidate may want to dive blindly into the problem. It is quite likely that one or two may miss the keyword major. The angle that is given belongs to the small arc, the minor one. In order to find the angle associated with the large arc, which is the major arc, we subtract that angle from 360 degrees. Now we have 60 degrees here, and this arc is a small one. It is called the minor arc, and this angle is responsible for this arc. The circumference of 20 centimeters will be multiplied by the fraction represented by the major arc, and that fraction is represented by what? Dividing the angle associated with this arc by the angle of one entire revolution. The angle associated with this arc will be the difference between this 60 and the 360, and that will be multiplied by the circumference, as we have it right there. Here we have an algebraic expression, and the options are telling us that we need to simplify this one. All that is required in solving this problem is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. So let us expand the brackets. So we have 5 times x is 5x. Then we have 5y. Then we have a negative 3 to be multiplied by x. We get a negative 3x. And we have a negative 3 to be multiplied by a negative y. Negative multiplied by negative is positive, and that gives a positive 3y. After that, let us combine the like terms, if any. So we identify the like terms and combine them. We have 5x minus 3x, that is equal to 2x. Then we have 5x plus 3y, that is equal to 8y. The correct answer is option C. If the simple interest on $800 for 3 years is $54, what is the rate of interest per annum? What is the rate of interest per annum? This is another simple interest problem in which the simple interest is already given and we need to find the rate. Including 100 in the formula for simple interest is a redundancy because the rate is already a percentage. Let us write down the formula for simple interest, and that is I is equal to principal times rate times time. Making R the subject may be achieved by dividing the left hand side by PT. We need to find the rate of interest per annum. We need to eliminate P and T. Divide by PT on the left hand side, and that is what the rate is equal to. Next, we will substitute the values. R, we do not know. The interest is 54, the principal is $800, and the time is 3 years. So principal $800, time is equal to 3 years, and the interest is $54. What do we do next? The fraction may be reduced by a common factor of 2. 2 into that is 400. 2 into 54, I think, is 27. Yes, I'm right. We may have a further reduction by a common factor of 3. So 3 into 3 is 1. And 3 into 27 is no more than 9. The answer is the fraction 9 over 400. That is the rate. Since the rate is expressed as a percentage, we will convert the fraction to percentage by multiplying by 100. We do that all the time. As a matter of fact, we have been doing that from primary school, converting a fraction to percentage by multiplying by 100. And what will happen? Reduce by a common factor of 100, and the fraction is 9 over 4. So the fraction turns out to be 9 over 4, which is equal to 2 and a quarter. 9 into 4 is 2 times, and the remainder is 1. So we have a quarter. The correct answer is option B. There we have an algebraic expression in which we need to multiply 2 terms. How do we do that? When multiplying algebraic terms, we simply multiply the coefficients first. So we have the 3, the 2, 3 2's 6. We are not done yet. We need to complete our task by manipulating the symbols, or letters, as we have them right there. When multiplying numbers, or letters in this particular case, that have the same base, we add the indices. So add the indices of the x's. We have x to the power of 2 plus 3. Finally, simplify the result. We have 6 and 2 plus 3 is equal to 5. So it is 6x to the 5th power, or 6x to the power of 5. The correct answer is option C. This may appear to be a simple problem. The fact is, some students are not aware of the simple rules that are used in the manipulation of indices. This is more evident when they try to make the transition into deciphering logarithms at the tertiary level. Logarithms are indices expressed in a different form. If you do not know one, it is next to impossible to know the other. And in any textbook that you have on logarithms, you should see quite a bit of discussion on indices. A salesman is paid 5% of his sales as commission. His sales for last month were $2,020. How much commission was paid? 5%. This problem is too easy to be true, as if our problem should take 2 pages of a police record book. We may first solve the problem by applying a bit of mathematics. The strategy for multiplying by 5 is to take half of the number and increase the result by 1 place of decimal. So, multiply by 5 by taking half of the number and increase the result by 1 place of decimal. Let's see how we do that. Of course, we are talking about 5%. The 5% we are mentioning, we will multiply by 5% by taking what? Half of the number, we get 1010. Then we increase by 1 place of decimal, we get what? 10,100. But do not forget that 5 is a percentage. The result must be divided by 100, reducing that figure by 2 places of decimal. Alright. The correct answer is option C. Alternatively, we may find 5% of 20,000. Alternatively, we may find 5% of 2,200. The fraction may be reduced by a common factor of 20. So common factor of 20, 20 into 100 is 5. And 20 into 20, we'll have what? 20 into 20 is 1. 20 into 2, 0. Then 20 into 20 is 1. So we have 101. No doubt, we may have a further reduction of the fraction by a common factor of 5. And 5 is gone and also gone there. On the next slide, we will take a look at how we may make quick calculations when dividing by 5. So we will take a look at what we will do when dividing by 5. 5 is equal to 10 divided by 2. This fact may be used in multiplying by 5 very quickly. So 5 is equal to 10 divided by 2, and we will use that fact when multiplying by 5 very quickly. So we have 368 to be multiplied by 5. Dividing 368 by 2 may be done mentally by taking half of 36, which is 18, and half of 8, which is 4. So half of 36 is 18, half of 8 is 4, so 18 4, 184. Then we multiply that by 10 and we get 1840. So we'll have 184 when we take half, then we multiply by 10. Therefore, the speed with which one may multiply by 5 is limited to the speed with which we may find half of the number. Half of any number may be found very quickly. Therefore, we may multiply any number by 5 very quickly. And that multiplication by 5 is dependent on the knowledge that 5 is 10 divided by 2. We just take half, that means we divide by 2, then we multiply by 10, which is, of course, merely increasing the number by a single place of decimal. We have 127 to be multiplied by 5. Half of 12 is 6. Half of 7 is 3.5. So we have 63.5. So when we divide that, we get 63.5. Then we multiply by 10, we get 635. It's as easy as that. So 5 is 10 divided by 2. Therefore, in multiplying by 5, we first divide by 2. Then increase the result by 1 place of decimal, which is the equivalent of multiplying by 10. If there is no decimal place, an additional trailing 0 will do. So, since we have 5 is equal to 10 divided by 2, if we are multiplying by 5, we divide by 2 and multiply by 10. It is as easy as that. So here we are going to apply this to decimals. What do we do? A half of 24 is 12. A half of 54 is 27. So we have 12.27. 12.27. Right. Increasing by 1 place of decimal, we get 122.7.